Hey, good morning and welcome to our training center. Today we're going to talk a little bit about MCAP. We wanted to address this product. It's been out on the market for several years, but we wanted to address the productivity and safety to it. So I'm Bill.Fowler. I'm one of the senior trainers here. I have Johnny.Sellers along with me.
Hey, Johnny.Sellers.
And he's going to help me do this demonstration today. So we're going to show you a testing station that we have to demonstrate the safety of MCAP. But first I want to start out, what is MCAP? So several years ago, Southwire developed a product called MCAP. This is a metal MCAP, that's AP's for all-purpose. What this product is, it's basically 15% smaller, it's 15% lighter, and it will trip to ground or trip to fault 15 times faster. The nice thing about this product being smaller is that it also, too, when you're installing this gives you a greater bend radius on this. As you can see here, the jacket won't separate. It being lighter, it's easier to tote, and with the jacket being a little bit stiffer, it allows you to form this product in a wall and kind of hold its shape, so it's easier to work with. So pretty neat, unique product. So I want to talk about some of the basic constructions of this. So let's talk about how it's made. So again, this is an MC product. You would normally use a roto split to cut the jacket on this. I've actually got our roto split that's made here in the USA. This is actually our auto crimping roto split. You have to look at one that can do a smaller diameter, which is auto crimping, works really well with this MCAP product. So basically you would do your roto split. I've already done that. I'm going to pop this off. So I'm going to show you here a little bit about the construction. What we have, instead of a normal copper ground wire, we have an aluminum ground wire. Why? Because if you'll notice, here is the mylar that is around the current carrying conductors. That aluminum is outside that mylar in the construction. And so what that does, that comes in contact with this outer jacket. This being aluminum, this needs to be aluminum. So we have similar metals. We don't have dissimilar metal problems. So what we would do is we would just take this ground wire, we would pull it out to the side, we'd pull the mylar out here. And so what I would do is just cut that ground wire off. Okay, and I also would strip my mylar off here. Now this mylar acts as an anti-short. Okay, so it's a great way of not having to use those anti-short bushings, but you can use those with this product. So let's talk about the connectors. All right, because that ground wire comes in contact with this jacket, now this jacket becomes a part of the ground path. Okay, so we've multiplied the amount of material that's toting that ground. What you would have is there's an IA rated connector. You have to make sure whatever connector you buy for MCAP has that IA rating on it. That's been tested with this product to make sure it can pass a ground through the connector to the box. So all I do simply would slide this through here. And this was just you hear it snap in place, boom. Now that is part of the ground path. So now when I terminate this into the box, that ground is going right into the box, and now the box is grounded without me having to land that ground wire. So that's basically the basic principles of MCAP. So what this does in productivity side is that I do not have to ground that ground wire to the box anymore. So that's 2.5 minutes per connection. So if you think about at the panel and at the box connection, that's 2.5 minutes. That's a 5-minute savings per circuit. So that is the basic construction of this. So what we wanted to show you next with our test station is with this ground coming in contact with this armor, how much of a safer install it is versus a typical grounded connection. Because again, we could lose that ground under a wire nut, and we'll explain that here next. So we're going to move back here to our test station. So what we have here is we've got a test station that is simulating 100 feet of cable. Okay, so 100 feet of MC cable. We have an aluminum MC, meaning aluminum jacketed. We have a steel jacketed MC, and then we have the MCAP product here. I can test several different ways with this test station. I can actually test the armor and the ground together. This is a fault test, so we're going to do a fault test on this. We're going to see how a fault acts in a real-world environment. Okay, so anyway, I can do the ground wire and armor, or I can just do the ground wire, or I can just test the armor. So for today's purpose, we're just going to test the armor. We know that the ground wire will work if it's terminated properly. we know that both of them together would work. So we want to just test if we lose that ground. So let's talk about the probability. If you've got a job with, say, 3,000 connections, what is the probability of one of those ground wire nuts not being terminated or either working themselves loose? Probability is pretty good. So what happens is until you have a fault or an accident, until somebody really has an accident, that's when you will learn that ground wire is not connected. So with this MCAP product, we don't have to worry about that. As long as that connector is in the box, your box is grounded. So again, what we're going to do, you'll see right here, we have an amperage reading. We also have a temperature reading. I know you can't see it on the camera, so I'm going to kind of read that out to you as we do this. So what Johnny's going to do, he is actually going to put power to we have our aluminum jacketed MC.
Wow.
You see the lights on, so we do have power going through this. So what he's going to do, he's going to induct a fault. So we're going to see how long it would take a breaker to recognize that fault. And again, this is simulating 100 feet of cable. So Johnny, go ahead and do that.
All right, so we're going to flip a switch and engage a short. Here we go.
We have a live fault. So my amperage reading is around 51 amps, 50 amps. I'm at about 75, 80. Now it's creeped up, 85.
There, the breaker just tripped.
So it just tripped. You saw the breaker trip. So it took a while. The breaker worked, but go ahead and energize. So it took a while, right? The breaker did work, but it took a while. So again, I talked about that 15 times faster. So let's go to, so what Johnny did in the back, we have a series of breakers. So we're going to go to a fresh breaker that's cooled down. So we have an apple-to-apple comparison. So now we're going to energize.
And 1.2, during that time between when we engage the short and the breaker trip, you've got live, someone could get engaged in that fault and get hurt.
Exactly. So that's what we're trying to show you here is, yes, the breaker worked, but it took a little while, right? So now we're going to go to steel. So what is the difference in steel and MC? We know steel has a higher resistance rating, okay? So we're going to see this energize, and we're actually going to see it. It's going to get hot. You won't be able to see it, but this is basically a conductive heater. We're going to turn this into a conductive heater. Because of the length of that cable, we're going to have a problem with this heating up, and then we could actually have, fault to ground. We can have a phase to phase. But anyway, we're going to go ahead and energize it and show you what happens with steel.
Yeah, let's see how long it takes a breaker to trip. Here we go. We're going to engage the fault.
All right, so we're pulling, it's creeped up to 21 amps. All right, so we're on a 20 amp circuit. That's not much out of range, right? But watch the temperature up here. You can see it. So we're at 80 degrees right now. Again, we're still live. There's a live current. I don't want to touch this. We creeped up to 88. We're at 90. We're getting up to 100 now. We're at 95.
Breaker's still holding in there.
It's still holding in there. All right, so we're at 100. So what, Johnny, we're going to go ahead and turn this off, because what will happen is this will keep going until we have a fire. Okay, that's something's going to melt. It's going to catch on fire. It's, somebody could have an accident, because again, it's not going to see that fault because of the resistance of that steel jacket. Okay. All right, so now we're going to go to MCAP. All right, so again, let's look at the box fill here. We're going to look at a panel here in a minute, but I want to talk about the box fill. You'll see here, look how crowded this is. We have the neutral, the phase, and the ground. Neutral, phase, and ground. Look how full. You can't really see this, but this box is full. So what do you think the probability, once you terminate a device and you shove it in that box, you could push a wire nut off? You can. If you look at this box right here, we only have our phase and our neutral. No ground wires having to be landed, so less box fill. Okay, that's an advantage of this product, is not having all that box fill there and having that accident of you shoving a device in there and pushing a wire nut off. We don't have to go with those double deep boxes, so you can't go shallower boxes. So again, it's just a better product all around on the install. So let's look at the fault. So again, we have current here. Look, we only have one light. I can't separate the armor and the ground, because guess what? They are the same construction. They're in contact with each other, so we can't separate it. So Johnny's going to do the fault. Now watch really close.
And we're using a fresh breaker back here. It's not been heated up. All right, let's see how long it takes it to trip. You ready? 1, 2, 3. Bam. It just that fast. It took that breaker out.
Instantaneous. So when I say that average fault on a aluminum jacket MC is about 152 milliseconds. On our testing on this is about 15 milliseconds. So a lot of people say, well, that's not much time. It's not much time unless you're the one holding onto that wire. Doesn't take very much to stop a heart. 2 milliseconds, you can stop a heart. So again, this is a much safer product in its design. That's the reason we designed this. And I'm gonna tell you a little story. When I was working with Southwire years ago, when they came out with this product, there was an accident that they documented. The child was at a pool, and he went and put a quarter in a Coke machine, or drink machine, and he got shocked because the ground was not terminated properly on the box. So that's just, things can happen, okay? When we lose that ground, we don't notice it until something typically happens or an equipment burns up, whatever. So that ground is that thing you don't see. The lights were on, even though I didn't have a ground. So that's why we want to have a product that makes this a safe install. So again, 15% smaller, it's 15% lighter, and here is the safety part of this. It trips 15 times faster. It sees that fault much faster than the traditional steel. Saw how steel did, right? Because of the resistance. That thing would just keep going until we made a conductive heater. So again, the great thing about MCAP is lighter, and it's much easier to install. It's going to save you time, less box fill. And for those engineers out there listening, this is a safer product. If that connector's in that box, then we're make sure we've got a ground. So anything you want to add, Johnny?
Yeah, the only thing I would add to it here is also, if you think about it, Bill touched on this, if you got a building with 500, 700 4-inch square boxes to make up, and you got 3 grounds in each box plus the greenies in there, how much time does it take to make up all those grounds in those several hundred boxes on a job site? It's a lot of time. So you get the savings of time making up these boxes, and like Bill said, the feel inside these boxes are much easier. And you go back to your panel board, so we're going to take a look at a panel board here. This is just a typical 225 amp 3-phase panel board. And you'll notice, you probably can't see it from there, but it's terminated across the top with the connectors that Bill showed you. There are no green ground wires from the branch circuits in this panel. You got your ground bus over here, your neutral bus is here, and there are no green ground wires to make up in your panel. So you've got labor savings there of not having to make up all those grounds and all those panels in that building. If you run into a situation where you want to use this product and maybe your engineer doesn't know about it, or in fact your local inspection department doesn't know about it, it's always a good idea to say, call them up, hey, just want to let you know we're using this product, and make sure that they understand it. So if your inspector comes out to your job site and he sees MC cable with no green ground, he doesn't freak out and causing issues. It's always good to get that up front, let them know you're doing that.
Right. So originally, that's why we built this test station, to Johnny's point about the engineers. They were just not familiar with this product. They didn't know how it would act. So that's why we really, probably 10 years ago, made these 2 testing stations. We have one over here that talks about the resistance, to look at aluminum ground versus a copper. They're pretty much the same. They're equal, because again, we do a 10 gauge ground wire in here because it is aluminum. So we do go up that extra conductor size to make like a number 12. So we do increase that ground size to equal it in aluminum. So again, it's a safe product, and this test station will demonstrate it. So if you have a situation with an engineer that really kind of cautionary about using this, get with us. We can we've got a video that we can show this. We can have engineers talk to them. But again, this is a safer product. Plus, it's for you contractors out there, it's much easier to install. All right. So we'll open it up for questions out there. I don't know if we're going to have any questions. So we will see if there's anything out there.
Thanks, Bill. I don't see any questions at this time, either on our Zoom feed or our YouTube channel.
Okay. So again, this product is available across the country, and it's, again, we offer this not only in our spools, but Carl, that's something we need to talk about here. We also offer this kind of in the corner here, see our barrel. So we offer this not just in your spools alone, but we also now offer this in our barrel configuration. So what's nice about this barrel configuration is that you get a lot of wire in one container, okay? So this 12.2 MC product right here in this barrel is like 2,500 feet in this barrel. That's 2 1,000-foot spools and a 500, okay? So you talk about waste on the job site. With that right there, I'm not having a lot of that waste left over on the end of the reel by having that package there. Plus, you just talk about, let's get back into the productivity thing. I've got one person that can move that barrel. Okay, it would take 2 people to move 1,000-foot reels of MC on a job site. Plus, you would have to have the stands to set it up. With that carts and the barrel, I don't have to have that stand. Okay, I can move it around the job much easier. It's going to cut down on my waste. You can get longer links, out of it. You're not limited to that 1,000-foot links. So again, there's just an advantage to this product in the way you buy it, even in the packaging. So again, this is just a greater product, and I love the flexibility. I mean, try to do that with a normal MC. That jacket would be splitting right now, right? So this product is I really love it, and because of the stiffness of it, it's easier to handle. You can look here. You ever get MC to stand up like that? No. So I like the rigidity of it, and contractors that I have taught with in the past, especially forming in walls, they love the way they can get it to form into a wall and stay, versus you have that big twist in there. So again, it's just a nice product. Again, it's been around for over 10 years. So, and it's still not widely used. And engineers say, why are you making regular MC and this MC? Well, people are still buying regular MC. But if this MCAP would have came out before normal MC, people would be using this because, again, it's a safer product.
Well, Elizabeth, any other questions out there at this point?
Johnny, I don't see any questions. You guys did a wonderful job.
Well, we just wanted to show this test station because this is a really good example of the people out there that see how this product performs. That's live, okay? There's no tricks to that. That is current going through that armor, and you see how a breaker reacts to it. And so when we have contractors come in the training center, they see that, they go, oh my gosh, it is a night and day difference than what they hear. They actually get to see it. So y'all got to see it today. We wanted to show this to share it with you today. So if there's no questions, thank y'all for joining us today. We can share a video of this if you need it, or we can talk to our cable tech support group. They can talk to engineers directly about this if you need help there on your local AHJs, understanding this product. But again, just got to make sure you got IA-rated connectors. And I tell you what, about 80% of the connectors out there, or probably more, are IA rated now. So they'll work on MCAP.
All right. Well, listen, thanks everyone.